The second one is law of double negation. Negation of a negation is logically equivalent to P. B conjunction C is logically equivalent to A disjunction B. A disjunction B conjunction A disjunction C. True and true is true. Again, true and false is also true. False and true is also true. Then false and false is false. Hello dear students, welcome to this session of Mathematical and Statistical Computing class. I am Mr. Niranjan, Faculty, Department of Computer Science, Vidhyaashram First Grade College, the Temple of Excellence. In my previous class, we have discussed regarding the construction of truth table for tautology and contradiction and some problems of a compound proposition. Today in this session, I am going to discuss regarding logically equivalence. So, logically equivalence and the problems related to logically equivalence. This is an important concept. Now, let us discuss what is the definition of a logically equivalence. Now, two compound propositions P and Q involving the same components are said to be logically equivalent if their truth values are the same for each different combinations of the truth values of their components, and it is denoted as P is logically equivalent to Q. So, if the truth values are the same for each different combinations of the truth values of their components, if the truth values for first and the second same, if the truth values for the first compound proposition and truth values for the second compound proposition are same, then the two compound propositions are said to be logically equivalent. So, some of the important logically equivalence propositions are, so demopotent law, that is P disjunction Q is logically equivalent to P. Similarly, P conjunction is logically equivalent to P. The second one is law of double negation. Negation of a negation is logically equivalent to P. If you negate a statement two times, definitely you will get the same statement. Negation of a negation is equal to P. Commutative laws. What are commutative laws? P disjunction Q is also equal to Q disjunction P. Similarly, P conjunction Q is also equal to Q conjunction P. Right? That is nothing but in algebra A star B is equal to B star A. So, if it is disjunction, P disjunction Q is also equal to Q disjunction P. Similarly, P conjunction Q is also equal to Q conjunction P. Now, move on to the next one is associative law. For associative law, this is very important. So, associative laws. So, in the examination, they will ask associative law, verify associative law using the truth tables. Now, very simple. The associative law is nothing but, let us take it as, let us consider A, B, C. So, if A disjunction B disjunction C is logically equivalent to A disjunction B disjunction C in case of disjunction. Similarly, in case of conjunction, A conjunction B conjunction C is logically equivalent to A conjunction B conjunction C. So, this is like A star B star C is equal to A star B star C. That's it. So, this is called an associative law. Okay. Now, move on to the next concept, distributive law. So, here P disjunction Q conjunction R is logically equivalent to P disjunction Q conjunction P disjunction R. That is, in case if you consider A, B, C, this is nothing but A disjunction B conjunction C is logically equivalent to A disjunction B conjunction A disjunction C. A disjunction, so that is P disjunction Q conjunction P disjunction R. Similarly, so if it is conjunction, you will get disjunction here. P conjunction Q disjunction R is logically equivalent to P conjunction Q disjunction P conjunction R. So, if it is disjunction, you will get conjunction here. If it is conjunction, you will get disjunction here in case of distributive laws. So, De Morgan's law. In De Morgan's law, negation of P conditional to Q is logically equivalent to P conjunction negation Q. And similarly, negation of P disjunction Q is logically equivalent to negation P conjunction negation Q. This is also very important. So, distributive laws, associative laws and De Morgan's laws are very important for the point of examination. Now, Move on to the next concept, negation of a conditional statement. Negation of P conditional Q is logically equivalent to P conjunction negation Q. So, negation of a biconditional, negation of biconditional is logically equivalent to P conjunction negation Q, disjunction Q conjunction negation P, right. So, negation of a conditional is P conjunction negation Q. Negation of a biconditional is logically equivalent to P conjunction negation Q, disjunction Q conjunction negation P. So, these are the logically equivalence for negation of a conditional and negation of a biconditional statement. Now, let us take few examples. Let us verify whether they are logically equivalent or not. Let me discuss few problems related to this logically equivalence. Now, prove that negation of P conditional to Q is logically equivalent to P conjunction negation Q. Right. Now, as usual, just split the table. P, Q, negation of Q, then P conditional to Q, negation of P conditional to Q, again P conjunction negation Q. Now, the truth values for P and Q. So, for P it is true, true, false, false, true, false, true, false. Okay? True, true, false, false, true, false, true, false. Now, negation of Q, negation for this. For T it is F, for F it is T, for T it is F, for F it is T. Now, conditional, conditional for P and Q. Conditional is true and false is false. In all cases it is true. True and true is true. True and false is false. False and true is also true. False and false is true. Right. Next, negation of this P conditional to Q. Negation for T it is F. For F it is T. For T it is F. For T it is F. Right. So, negation of this, negation of true is false. False is true. True is false. True is false. Now, the second part. Last part. What is last part? P conjunction negation Q. P conjunction negation Q. Conjunction for these two. So, for conjunction true and true is true. In all cases it is false. So, P conjunction negation Q. True and false is false. True and true is true. Again, false and false is also false. False and true is also false. Right. See, conjunction for P negation Q, that is true and false is false, true and true is true, false and false is false, false and true is also false. Now, if you observe carefully, let us represent this as first column, second column, third column, fourth column, fifth column and sixth column. Now, just what is the left hand side here? Negation of P conditional to Q and P conjunction negation Q. If you observe carefully, the truth values of fifth and sixth column are same. In fifth column, false, true, false, false. Sixth column, false, true, false, false. So, these two are same. That means, the truth values of fifth and sixth column are same. Therefore, they are logically equivalent. So, these two are logically equivalent. Therefore, what is the conclusion? Negation of P conditional to Q is logically equivalent to P conjunction negation Q. So, these two are logically equivalent, right. So, the truth values in fifth and sixth column are found to be same. Then, the conclusion is they are logically equivalent, right. This is how we are going to verify the logically equivalence. Now, move on to the next example. Examine whether the following are logically equivalent or not. P conjunction negation Q, disjunction Q, and the second part is P disjunction Q. So, we have to verify whether this is logically equivalent to this. Now, as usual, write down the truth table. P, Q, negation of Q, P conjunction negation Q, again P conjunction negation Q, disjunction Q and P disjunction Q. Now, the truth values for P are same. True, true, false, false. Here it is true, false, true, false. Now, negation of Q. For T it is F, for F it is T, for T it is F, for F it is T. Now, write down conjunction for P and negation Q. So, for these two, write down the conjunction. Conjunction true and false is false, true and true is true, false and false is false, false and true is also false. Right. P conjunction negation Q, disjunction Q. So, P conjunction negation Q, disjunction Q means just for these two, we have to write disjunction. Now, disjunction means false and false is false. In all cases, it is true. Right. So, P conjunction negation Q, disjunction Q. False and true is true. True and false is also true. False and true is also true. False and false is false. right? Okay. Next, the last column is P disjunction Q. The disjunction for this two. True and true is true. Again, true and false is also true. False and true is also true. Then false and false is false. Now, just represent this as first column, second column, third column, fourth, fifth and sixth. What do you say? The truth values in fifth and sixth column are found to be same. True, 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 false, false. So, T, 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 F, T, 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 F. So, these two are found to be same. So, therefore, they are logically equivalent. That means, what is the conclusion? Therefore, P conjunction, negation Q, disjunction Q is logically equivalent to P disjunction Q. That's all, right? So, this is also an important problem for 6 or 7 marks, right? Now, move on to the next similar type problem. Prove that P biconditional to Q and negation P disjunction Q conjunction negation Q disjunction Q is logically equivalent or not. Same. P biconditional to Q, negation P, negation of P disjunction Q, negation Q disjunction P and the conjunction for these two. Now, as usual, write down the truth values T, T, F, F. So, this is T, F, T, F. Now, biconditional, true and true is true, true and false is false, false and true is also false, false and false is true. Now, negation of P, for T it is F, for T it is F, for F it is T, for F it is T. Next, negation of P disjunction Q, this and Q, disjunction for these two. So, disjunction means false and false is false, in all cases it is true, false and true is true, false and false is false, true and true is also true, true and false is also true. Now, negation of Q, for T it is F, for F it is T, for T it is F, for F it is T. Now, then negation of Q disjunction P, negation of Q disjunction P, these two. For this we are going to write the disjunction. So, negation false and true is true, true and true is also true, false and false is false, true and false is also true. Now, these two are connected, negation P disjunction Q and these two are connected by a conjunction. So, these two are connected by a conjunction. Conjunction for this, true and true is true, false and true is false, again true and false is false, true and true is equal to true. Okay. Now, just verify whether these two are equal or not. So, that is, let us represent this as first column, second, third, fourth, fifth, sixth, 7 and 8th column. So, verify the truth values in third column and the last 8th column. So, if they are equal, then they are logically equivalent. So, true, true, false, 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 true, true. So, that means third column is equal to 8th column. The truth values in third and 8th column are found to be same. So, they are logically equivalent. So, how to conclude? Therefore, P biconditional to Q is logically equivalent to negation of P disjunction Q conjunction negation Q disjunction P. They are logically equivalent, right? So, very important problem. Now, move on to the next problem. The next problem is P conditional to Q conjunction R is logically equivalent to P conditional to Q conjunction P conditional to R. Now, as usual, P, Q, R, Q conjunction R, P conditional to Q conjunction R, again P conditional to Q, P conditional to R, and these two are connected by the conjunction. Write on the truth values. So, truth values for P, Q, R is first 4 are true, true, true. Next 4 are false, false, false. Next 2, 2. T, T, false, false, true, true, false, false. Next, this is for R, it is alternative true and false. True, false, true, false, true, false, true, false. Right. Now, conjunction for these two, Q and R conjunction. So, true and true is true, true and false is false, false and true is false, false and false is false, true and true is true, true and false is false, false and true is false, false and false is also false. Conjunction. Now, P conditional to Q conjunction R. For this, P and conditional for these two. P conditional to Q conjunction OR. So conditional is true and false is false. In all cases it is true. True and true is true. True and false is false. Again true and false is false. True and false is false. Again false and true is true. False and false is also true. False and false is also true. False and false is also true. Next, P conditional to Q. P and Q conditional. So true and true is true. True and true is also true. True and false is false. Again true and false is false. Remaining cases are true, 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 true and true. Now, conditional for P and R. P, Q, again P and R. Right. Same P and R for these two conditional. So true and true is true. Again true and false is false. Again true and true is true. Then true and false is false. Again false and true is true. Again false and false is true. False and true is also true. And again false and false is also true. So these are the truth values. Now these two are connected by conjunction. So P conditional to Q conjunction P conditional to R. These two are connected by conjunction. So conjunction true and true is true, true and false is false, false and true is false, false and false is false, true and true is true, true and true is true, true and true is true, true and true is true. Right. Now observe carefully. Here this is first column, second, third column, fourth, fifth, sixth, seventh and eighth. So you observe carefully. P conditional to Q conjunction R. This is fifth column. The truth value is in fifth column and the truth value is in eighth column. Verify whether they are equal or not. If they are equal, then they are logically equivalent. So T, T, F, 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 T, 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 T. So that means the truth values in fifth and eighth column are found to be same. So therefore they are logically equivalent. So here the truth values in fifth column and eighth column are same. So therefore they are logically equivalent. What is the conclusion? P conditional to Q conjunction R is logically equivalent to P conditional to Q conjunction P conditional to R. This is an 8 marks question, very important. So you should be careful while writing the truth values in case of P, Q and R. Okay. So this is how we are going to verify logically equivalence for this type of problem. Hope you followed. So these are few examples for logically equivalence. You may expect one question from this type for 7 or 8 marks in your final examination. So that's all regarding today's session. Let us meet with a different concept in the next session. Thank you very much.